Welcome to this video. So basically, we are going to solve some questions on the chapter of fluid mechanics. So let's begin. So the first question which we have is a rather simple one. We have a soap solution, and that soap solution is uh, constrained within this U-shaped smooth wireframe in which a slider can slide down. So we are supposed to find what is the surface tension uh, of the liquid if the slider is massless and this mass is some mass m, and the length of this slider is some distance l. So this is what we did in the last video. We'll say that the surface tension is some sigma. So sigma into L, that is the force exerted by one layer of the soap film or one surface of the soap film on the slider. Layer is the wrong word, surface is the right one, right? Uh, so the surface beneath this soap film will also exert this force. So this would be the net force. This would be balancing the downward force, gravitational force mg acting on the slider. Surface tension acts like this. So that means that surface tension is mg upon 2l. So this was our first question, rather simple one. Next, let us begin. So we have a rectangular plate. Uh, Now, what's so special about this rectangular plate? We are going to dip this rectangular plate um, lengthwise uh, on the surface of a liquid. So we are given the surface tension of the liquid, that is, it is abbreviated as ST, is equal to 7.0 into 10 to the power minus 2 Newton per meter. So we have some kind of liquid. That liquid is has a surface tension this much, 7.0, 10 to the power minus 2. Uh, we are supposed to figure out if there is a rectangular plate, if we have dipped a rectangular plate like this, in our liquid. So this is the liquid which we have. This is the liquid which we have. This is the liquid in which we have dipped this uh, rectangular plate. So as we have dipped this rectangular plate like this in this liquid, we are supposed to find out if we dip it in such a way that this particular length is some 6 centimeter, the length is 6 centimeter, the breadth is 4 centimeter, and the width of the that is the thickness of the plate is 2 mm. Thickness is 2 mm. So if it is placed like this, then what will be the force of surface tension? What will be surface tension force? So it is not framed it like that. It has said the exact wordings. What is the downward force on the plate due to surface tension? So that is the one thing which I want to focus on. How is the surface tension exerting a force on this plate? Okay, so the drawing is pretty poor, but I'll just draw it in a better way. So this is the plate which we have like this, and this is the surface, kind of surface it is making. So, but it is water only actually. So, we know that the angle of contact for water is 0 degree. Angle of contact of water is equal to 0 degree. So, as angle of contact of water is 0 degree, basically it will form a surface somewhat like this. If you can see that, how that surface is being formed. So, this is the surface basically with which the water is in contact with, and the uh, liquid layer is forming a surface like this. It is like uh, touching this water surface at 90-degree angle. So it is basically curved like this. So like if you draw a tangent at this point where the liquid layer is touching this rectangular plate, then that tangent would be at 90 degree with the surface of the rectangular plate, because the normal is somewhat like this. This is the normal and this is the surface tension force, how the surface tension is going to act. So this normal and the direction of force of surface tension are making an angle of 90 degree. So the surface tension force just acts like this, F, vertical, like this. So I hope it is clear that angle of contact of water is 0. So the normal will make a angle of 90 degree with the force. So simply speaking, we will multiply the surface tension sigma or St with this whole perimeter of the plate. So the question has different parts. The first part is that the first part is the plate is dipped like this. So uh, we'll say 7.0 into 10 to the power minus 2 into 6 plus 4 times 2. So that would be 20 centimeter, or 20 into 10 to the power minus 2. So this will become some 1.4 into 10 to the power minus 2 newtons. So this would be the net downward force acting throughout the perimeter of the plate, or on all the or everywhere on the perimeter of the plate in downward direction. Next, what will be the force on the second largest face of this plate? This is the B part. So it would be simple only. What would be the second largest face? Second largest face would be, there are basically three kinds of faces of this plate. First plate was the largest one, that was 6 into 4. Next we have 6 into 2 mm, right? The 6 centimeter length and this 2 centimeter thickness. If the plate is dipped like that in the fluid, then we will say that okay, on this perimeter the whole uh, surface tension force will act. So this would be 6 into 2, simply like that. So the net force would be 7.0 into 10 to the power minus 2 into 6 plus 2. So that would be 6.2 times 2 into 10 to the power minus 2. So this value will be some uh, 12.4 into 7. So 7 4 is 28, 7 to the 14, and 7 was the 7th, so that is 86.8 into 10 to the power uh, minus 4 Newton Newton force. So this would be on the second largest phase. Then what about the smallest phase? So in the same way, we can calculate the force on the smallest phase as well.